Here in session 98, we're going to be taking a little bit more look at irrational numbers. In the previous session, we saw that the large majority of square roots of integers or fractions will produce irrational numbers as their answers. In other cases, they do produce rational numbers. Well, that same pattern holds true for the nth power or the nth root of any number. But first of all, let's look at this first sample here. Y equals x to the third power. Well, another way of pronouncing this is y equals x cubed. X to the third and x cubed are the same thing. Then going the other direction with it, x equals the cubed root of y, or the third root of y. That's how you would pronounce both of these. Here we have y equals x to the n power, or y equals x to the nth power. And then the way we pronounce this would be x equals the nth power of y. So if n is 5, we would say x equals the fifth power of y. If n is 11, we would say x equals the 11th power of y. If n is 11 up here, we would say y equals x to the 11th power. If n is 6, we would say y equals x to the 6th power. So just be aware of the manner in which we pronounce these different types of roots, depending on the exponent that's being used. Now, just as the case of square roots producing a large majority of irrational numbers, the same is true for a root to any degree or to any power. But on this page here, what we're going to do is take a look at some roots of numbers that actually are rational. Let's take a look at our first one, the cubed root of 27. Well, what is the cubed root of 27? It's 3. Why is it 3? Because 3 times 3 times 3, 3 is used as a factor 3 times, and that 3 matches the 3 that's in our root here. 3 times 3 times 3 equals 27, and 27 is the number that we started with inside our radical sign. What about the square root of 4? What's that equal? Well, that equals 2. And why is that? Because 2 times 2. 2 used as a factor 2 times, and that 2 comes from our square root here, even though the number 2 is not written in front of the radical sign for a square root. It is understood to be there regardless of whether we write it there or not. So the reason why 2 is the square root of 4 is because 2 times 2 equals 4. What about this one? In this example, we have the fourth root of 256. So what number multiplied by itself, or being used as a factor 4 times, will give us 256? Well, the answer here is 4. Why is 4 the fourth root of 256? Because 4 times 4 times 4 times 4 equals 256. 4 uses a factor 4 times, and that matches that 4 there, gives us 256. And this time I'm going to pull off one here that's not on the screen. Actually, I'll just write it down here. What if we had the fourth root of 16? And what would that be? Well, that would be 2. And why is that? Because 2 times 2 times 2 times 2. 2 being used as a factor 4 times, and that matches our 4, that's our root number out here. 2 used as a factor 4 times will give us 16. Each of these 4 examples that we've calculated answers for are all rational. Well, what about if we were to try to take the fourth root of a fraction, 1 over 256? Will this have a rational answer? Well, it will only have a rational answer if both the numerator and denominator are the fourth powers of another integer. Well, is 1 the fourth power of another integer? It sure is. It's the fourth power of 1. And that's because 1 times 1 times 1 times 1 equals 1. What about 256? Is it the fourth power of another number? Yes, it's the fourth power of 4, just as we showed up here, because 4 times 4 times 4 times 4 is 256. So what is the fourth root of 1 over 256? The answer is 1/4. And why is the answer 1/4? Because 1/4 times 1/4 times 1/4 times 1/4. 1/4 is used as the factor 4 times. That matches the 4 out there. And when you multiply that out, that gives you 1 over 256. And that is the number, the fraction that we started with here on the inside. So I wanted to show you that the cubic roots, the fourth roots, the square roots definitely have answers that are rational numbers, but the high majority of the cases, they produce irrational numbers. And that takes us to our review. If a fraction is already in lowest terms, then the nth root of that fraction will be rational only if both the numerator and denominator are both nth powers of integers already. And lastly, just as the large majority of square roots produce irrational numbers, so do the large majority of nth roots produce irrational numbers. That'll finish up session 98.